I'm Anil Kumar. Welcome to my YouTube channel and the website Global Math Institute. Here is a brilliant question from one of our subscribers. Let me thank all of them for participating actively and promoting and making this YouTube channel very valuable for all. We need to integrate from 0 to 1 over x squared plus 1 whole square. Now, to integrate, we need to do substitution. Trigonometric substitution in this particular case. You could substitute x as tan theta or cotangent theta, right? So whenever you have x squared plus 1 in the denominator, that is one of the best substitution. Let us do x equals to cot theta in this particular case. Now, in that case, if x is equals to cot theta, then the derivative dx will be equal to what? Dx is going to be minus cosecant square theta. So that is one part. We can replace dx with minus cosecant square theta. The other part is what happens to the lower and the upper bound of this integral. If x equals to 0, that means 0 is equals to cotangent theta. Now that will happen when theta is equal to pi by 2, right? And when x is equal to 1, which is equal to cot theta, that will happen when theta is equal to pi by 4. So with this, we could rewrite our integral as equal to what? We could rewrite this as the limits. Instead from 0 to 1, now it becomes pi by 2 to pi by 4. And since we did x squared as equal to x equals to cot theta, we have 1 over. Now dx we could write as minus cosecant square theta d theta, right? And in the denominator, we have x squared plus 1 whole square. X is cotangent, so we have cot square theta plus 1 whole square. Makes sense, correct? So that is how the trigonometric substitution will take place. I hope the steps are absolutely clear. Now, since we have this minus, and you also see that the lower bound, is pi by 2, so that minus helps us to make it normal. So we make that as plus and change the limit from pi by 4 to pi by 2. Make sense? And so we have cosecant square theta over, let me write d theta here itself. 1 plus cot square theta is cosecant theta, right? So that will be replaced as cosecant 1 plus cot square theta as cosecant square theta whole square, means to the power of 4. Correct. So that becomes our equivalent integral while taking this, correct. So now you can see cosecant square theta will cancel. So we have 1 over cosecant square theta, which basically is, cosecant is the reciprocal of sine, right? So it's basically sine square theta, right? So we could rewrite this as, let me use a different ink here, from pi by 4 to pi by 2. So this cancels, and 1 over cosecant square theta is sine square theta d theta. So effectively, the integral given to us from 0 to 1 of 1 over x squared plus 1 whole square dx can be written as integral from pi by 4 to pi by 2 sine square theta d theta. Make sense? So now let's see how do we integrate this. Let's go to the next page. So this part we have just done. By substituting x equals to cotangent theta, we have written 0 to 1 integral of 1 over x squared plus 1 whole square dx equals to pi by 4 to pi by 2 sine square theta d theta. So let's find the integral of sine square theta d theta. So we could do this as equal to, so from pi by 4 to pi by 2. Sine square theta can be written as in double angle formula. We could write this, right? So you could write sine square theta. Let me write down cos 2 theta formula and then we'll rewrite this, right? So cos 2 theta is 1 minus 2 sine square theta, correct? So from here you can see that sine square theta is equal to, when 1 minus cos 2 theta over 2. Okay, so that is the substitution which we are going to do. So we can write sine square theta as 1 minus cos 2 theta over 2 d theta. Correct? So now the integral of this is, we can take half outside. We have 1 minus cos 2 theta, for which the integral is theta, and cos 2 theta integral is sine 2 theta divided by 2, right? And the limits are from pi by 4 to pi by 2. Clear? So that is where we are. And now we are going to substitute and find the answer. Okay, so now let's substitute the values and calculate. So for pi by 2 minus sine 2 times pi by 2, right, over 2. So that is the first part, minus, let me write within bracket, pi by 4 minus sine 2 times pi by 4 over 2. Correct. And that gives you half times. Now pi by 2 minus pi by 4 is pi by 4. Correct. Now we have minus sine 2 times half will be, there'll be sine pi, and sine pi, as you know, is 0. So this is 0, minus. We have already taken care of pi by 4, and minus becomes plus when you open the bracket. And here we get half sine pi by 2, and sine pi by 2 is 1. Okay, great. That gives you half pi by 4 and plus half. Correct. So you can now multiply by half and you get the answer, pi by 8 plus 1 by 4. So that becomes the integral of the given function from 0 to 1. So I hope each and every step is absolutely clear. Feel free to write your comment, share your views. If you really want to take some lessons, you can always send an email to globalmathinstitute@gmail.com. Our students are right there on the top, getting the best grades. Thanks for your valuable time and all the best.